Hi, in this recording I'm going to talk about const. So you have heard this before. Let's say taking this previous example where we have an integer declared which is called num, and I can make it a const, or I'll just declare a new variable const int value equals 10. Okay, so now once we say that this variable is a constant or a const, it's something like final in Java, where now once we have assigned a value, this variable I can print it. So if I run this code, you can see value will be 10 and it will print 10, as you can see here. Okay, now if I try to change this value and say value equals 5, compiler will refuse to compile this code because we already said this is a const, and only const means this variable can be initialized only once, which we are doing here, and so we cannot assign a value again. So once we do this and I try to compile, you can see it says assignment of read only variable value. Read only, of course, means that you need to assign a value once to initialize, which is we are doing it in line 18. But then if you use it with another assignment, you will get a compiler error. So that's const in general. Now, how do we use it with a function? So we talked about this function before. This is a simple function that takes in a reference to a variable. It doesn't have to be a reference, but let's say if it's a variable which is a reference, and why we use references is so that we don't have to make a complete copy of an object or a value, and we can just refer to the original value. And the drawback of that is that if I make a change, as we saw last time, if we make a change in the variable, this value is actually referring to the original variable, so the original variable will change. So we are getting the benefit of efficiency, that we are not making a copy of the object, and so that's faster because if you only need to read the value and not change it, so we have the benefit of efficiency. But then the drawback is there is a chance if I don't want to change the variable, but by mistake I may change it. So therefore we use const, which is a good practice or a recommended practice if it is guaranteed that this function, my function, has no need to change this variable val, which is a reference to another variable like here. Then we will make it a const. So we will add the keyword const here, and now if I compile the code, you will see that I will get a compiler error on line 8, which says assignment of read only reference val. So this is again similar to the error we just saw. It's a read only. So first time when you call the function on line 22, the value num, or the variable num, is a variable holding value 16, and this parameter val is referring to this argument num. I'm making a slight distinction between parameter and argument, so we call these as parameters. So this is a const reference parameter, and the actual value that's passed is called the argument. Sometimes the terminology used is formal parameters and actual arguments. So this is a formal parameter and this is an actual argument that is passed. So sometimes this subtle distinction is made between these two words. Most of the time parameter and argument is used interchangeably. So going back here, the parameter val is now referring to this argument num excuse me, and so the value, whatever is in num, we are this variable will have the same value, that's 16, and that will be printed. But now as soon as we try to change it, the compiler says that we have this reference as const and we cannot change it. So why do we do this? We do this because we want to make a reference to the original variable instead of creating a copy, first of all, and that's for efficiency, and just to avoid changing the val, because there's no need to change it in this case, so we make it const. So that makes it perfect, like we are taking care of any avoiding bugs that way, and that's a standard practice, and that is something that we will follow in all along, that whenever we are not going to change the variable, we are going to make it a const. Now another thing that you may have seen, and this is maybe something new but it's important, is that sometimes functions like this, for example accessor method for make. Now this is an accessor method, or let's say take this example, print. Print is a function that let's see the definition here. The print function is the only job of this print function is to print the make, model, year, and owner's name and all that. So there is nothing that we are changing the instance variables, in this case the data, that's all unchanged. So to tell the compiler that or to promise the compiler that we are not going to change anything in this method, same thing with accessor methods, we are going to add const. Now interesting thing is that you may have noticed probably you have heard about this is this as a keyword, and you know that this is a reference or a pointer to the object which calls a non-static method. So let me explain this because it's important. So in main, let's say if I create a object called car and say car.print, and I'm going to comment all this code for now. So now car.print, we know that print method is a method in car class. We are calling on this object car. So when the print method is executed, this method which belongs is in the class needs to know which object is calling print, and that's a very important thing because there may be many objects of car class and we are calling print on a specific object. So what are we going to do now? So this is a pointer to the object that is calling the print method, because as I said, there may be many objects that exist of car class. So we want to tell this method that which particular object is calling the print method. So this is a pointer to the object that's calling this method. It's passed implicitly. So when we say this dot, you can see we see make, model, owner, year, and so on, because this is a pointer and we can access the individual data members or instance variable through this pointer, although it's not required in many cases because that's clear that we are talking about the object's instance variable, so we avoid that, but we don't have to use this. Why that is important is because when we say now I said that when we are going to call car.print, this car object or the reference or address to this car object is passed implicitly to the print method, and then what we are saying is that this print method shouldn't change this car object, which means that in car.h or car.cpp, the object that was used shouldn't be changed, and so therefore this is almost like you can see this as a pointer called this, which is passed implicitly, and now where we are saying that's a const pointer, which means we cannot change this object. And to do that, because this is an implicit parameter, we cannot put const in the parameter list, but we can put a const at the end of the function. So this const at the end of the print function says that whoever calls that we are not allowed, and we have to change this here also, that we cannot change any instance variables of the object inside the print method. So for example, I'll show you. If I say make equals 10, or whatever, actually make equals xyz, we will get a syntax error saying that this is a const. So you can see here, passing const string as this argument. So there are a lot of errors on line 48, and of course this owner.name is also now saying that you are promising that we are not going to change any of the methods or any of the objects, but we don't know if name is, this method name is going to change the owner object, and so therefore we get two errors. Now how to fix? Of course we are not going to change this, but now this name method, so pay attention here, the name method which belongs to person class, this is the accessor. Now accessor don't change anything, so we have to add a const here also, and this yellow bulb is helpful because it also applies the changes to the definition. And now if I go to car.print, we are promising that this name method is not going to change the owner object, and of course that means that none of these make, model, year and owner are going to be changed, because this print method is a const, this parameter is const. So if I compile this code now there is no compiler error, and of course we need to only make one change here, which is, well, there's no change here, but I can run the code now, and you can see this shows you one argument constructor of person class called, default car class constructor called, and this is the print method. So what we learned is we can make a method const, which means this method is not going to change the object, and that we should do usually with all the accessor methods, because accessor methods are only giving access to the instance variables and they are not really changing anything. So same here for make. Okay, and then we will see the more uses of const later on, which for copy constructor we do need const to be passed here, which is again promising that this variable val will not be changed in the method. Okay, so I'll pause this recording. Thank you.